Chapter 2, Section 9 is entitled Equivalent Fractions and Mixed Numbers. So let's take a look at what we're doing here. Our objective here is to be able to identify, write, and convert between equivalent fractions and mixed numbers. So we're working just with fractions really here today. So, some definitions. What are equivalent fractions? Equivalent fractions are different expressions for the same non-zero number. Different expressions for the same non-zero number. For instance, what they would be talking about there, let's say we were talking about 4 over 2 and 8 over 4. Now, yes, I picked fractions where the numerator, the top number, is bigger than the denominator, the bottom number, but it would work the same either way. Okay? I'm picking these because we can all do that division right in our head. 4 divided by 2 is 2. 8 over 4, 8 divided by 4 is 2. Because those both represent 2, they are equivalent fractions. That's what we're talking about when we're talking about equivalent fractions. Relatively prime, numbers that have no common factors other than 1. Numbers that have no common factors other than 1. Now, let's clarify a little bit here. Relatively prime does not have anything to do with the numbers themselves being prime. It does not mean that. I know that's a logical conclusion from where we've been to where we are right now, but that's not what it means. What the term relatively prime implies is that there's no factors in, really what they're talking about here is the fractions, in the numerator and the denominator that I'm going to be able to take out. For instance, let's go with 4 ninths. Right now, if it's bothering you that I'm already talking about fractions, even though we haven't given you an example, I'll make it better for you. Let's just talk about 4 and 9. Okay? Give me the factors of 4 and 9. Well, you know that 4 is 1 and 4, because 1 times 4 is 4, and 2 in itself, because 2 times 2 is also 4. 9. All right, 1 times 9 is 9. 3 times itself is also 9. All right. So we would agree right now that these are both composite numbers because there's something on that list other than 1 in itself. Correct. These are composite numbers. These are not prime numbers. However, they are relatively prime. Look at what the definition says. No common factors other than 1. The only number that's on both of these lists is 1. So even though they're not prime numbers, they are relatively prime. And that's what that definition says. Okay, so with that stuff in mind, let's go ahead and take a look at number 1 here. In number 1, we're supposed to find two fractions equivalent to 5/7. Now, most of us, when we think of equivalent fractions, we probably think reducing fractions and making them smaller. But it doesn't necessarily have to become a fraction that's smaller. It can become a fraction that's bigger. As a matter of fact, smaller isn't even an option because 5/7 is actually fully reduced. I can't make that any smaller. So you have to make it bigger. So, when we're finding an equivalent fraction here, one of the easiest things to do is to double the fraction. Now, don't tell me that doubling the fraction means multiplying by 2, because that's not really what I mean. Because if you multiply 5/7 by 2, what you really mean is 5/7 times 2, or 5/7 times 2 over 1. All right, that's not what I mean. When I say double the whole fraction, I mean multiply the top by 2 and the bottom by 2. All right, I don't want to just say multiply by 2 because that's not what I'm doing. All right, so I multiply the top and the bottom, the numerator and the denominator by 2. 5 times 2 is 10. 7 times 2 is 14. So 10/14 is equivalent to 5/7. Okay, let's try this again. Because they said find 2, so now they decided instead to multiply by 3. All right, so we're going to triple the top and the bottom, the numerator and the denominator. So I do 5 times 3, which is 15, and 7 times 3, which is 21. And we end up with 15/21. There's your other equivalent fraction. Now, here's a tip. 3, it's not the worst in the world, but there's actually an easier number to use. And you say, what could that number possibly be? That number is 10. Think about what multiplying by 10 really does. Because we're talking about a proper fraction, a real fraction, no decimals in there, multiplying by 10, in most cases here, is just going to add a 0. So in the second one there, 5/7, had I multiplied it by 10, again, when I say that I mean multiply the top by 10 and the bottom by 10, right? 5 times 10 is 50, 7 times 10 is 70. 50/70. Really easy answer. Add a 0, add a 0. All right? The times 2 option is probably the easier one. All right? Especially if I'm talking about between 2 and 3. Times 10 should be really, really easy because there really shouldn't be much thought there. Multiplying by 2 should be probably right on down the list, though, in terms of ease. Okay, let's take a look at number 2. We're writing the fraction 18/24 in simplest form. So here's where we come back to that definition of relatively prime. All right? We know a fraction is fully reduced if the number in the numerator and the number in the denominator are relatively prime, meaning they have a greatest common factor of 1. All right? These two do not have a greatest common factor of 1. So that's the challenge here. Now, what they decided to do, and really what I want you to focus on here, is I know you could look at this and say, well, it's an even number and an even number, so I'm going to divide out 2. And if when I do that, I get another even number and another even number, I'm going to divide out 2. And if I get another even number and another even number after that, I'm going to divide out 2 again. And you're going to keep dividing out 2 as long as you can because that's easy. That's not really what they want you to do here. They want you to do a one-shot reduction. Take out the greatest common factor right away, which is why this is in the same unit as greatest common factor. We've practiced greatest common factor. Now they want you to use it. So here, all right, you can find greatest common factor either way you want, but what they decided to do was the factor tree technique. All right, I won't go through the factor tree technique, but I will refresh your memory on how to do this. What you want to do is they've listed those factors, 2 times 3 times 3 for 18, and 2 times 2 times 2 times 3 for 24. Circle the number that's in both lists, or any numbers that are in both lists. Well, you got a set of 2's in those lists, and a set of 3's in those lists. Pick a row, top or bottom. All right, I'm going to pick the top. Multiply together what you circled in that row, and that's the greatest common factor. Well, I circled 2 and 3, so I'm going to multiply together 2 and 3, which is 6. So the greatest common factor is 6. That's the number I'm now going to divide out of the numerator and the denominator. So I do 18 divided by 6 and 24 divided by 6, which is what you can see they're showing right here. 18 divided by 6 is 3, 24 divided by 6 is 4, and there is your fully reduced fraction. 3/4 done. Okay, so number 3. Determine whether the fractions in each pair are equivalent. The only way to compare two fractions is to get them so they have a common denominator. Now, how you get common denominator, that's up to you. You could end up making one fraction bigger, you could make one fraction smaller, you could make both fractions smaller, you could make both fractions bigger. Whatever you have to do, but you have to do it with a common denominator. That's the only way to compare fractions. All right, so that means the bottom number has to be the same to make this happen here. So, in order to do that on this question, what they're asking us to do is to reduce these down so that they both have a denominator of 3. Now, some of you are saying, Bill, that's extra work. You're right, that is a little extra work. Why is that a little extra work? 6 can be changed into 42. We know that 6 times 7 is going to give me 42. So yes, I could make this go up to 42 and then just compare the numerators. Very true. But because they've asked me to make the bottom numbers both into 3, that's what we're going to do. Now, let's talk about how we do that. All right? Since they're telling us that the bottom number is going to be 3, we don't have to question that. Okay, so I say to myself, how do I change 6 into 3? Well, to go from 6 to 3, I'm dividing by 2. So you're going to do the same thing in the numerator. Whatever you do to the bottom, you have to do to the top, and vice versa. So since I said divide by 2 here, I'm going to divide the top by 2 as well. Now, just to make sure this is clear, you have to pick multiplication or division for your operation there. You cannot add, you cannot subtract. All right, so saying, well, I subtract 3, that doesn't work. You have to choose multiplying or dividing. Now, some of you are sitting here going, well, wait a minute, multiplying, what are you talking about? Realize that dividing by 2 is the same as multiplying by 1/2. So, really, it is dividing, even though it's multiplying by a fraction. Same thing. So you get your option there. So, I'm going to take my 4 and divide it by 2, and you get 2. And the bottom number, of course, is 3 because that's what they told me to do, 2/3. Okay, bottom fraction. How do I change 42 into 3? Well, I change 42 into 3 by dividing by 14. So I'm going to divide the top by 14 as well. When I take 28 divided by 14, I get 2 as well. And again, the bottom number has to become 3. At this point, we can compare the fractions because they have the same denominator. All we do is compare the numerators. You compare those numerators, the top numbers and the fractions, the same way you would as if they were just regular old numbers like 7 and 9. Since they're both 2, right, that means the fractions have to be equivalent. Now, here's another question. 6/10 and 20/25. And they've decided that they want us to do this by making both of the denominators 50. Okay, so I'm going to change 10 into 50, and I'm going to change 25 into 50. So let's start with 6/10. To change 10 into 50, you'd be multiplying by 5. So I multiply the top by 5 as well, and 6 times 5 is 30. So you've got 30 50ths. To change 25 into 50, I'm multiplying by 2. So I do the same thing at the top, and I have 40 50ths. So now I'm going to say to myself, how am I going to compare these guys with numerators of 30 and 40? All right, well, 40 is bigger. So 40 50ths would be bigger than 30 50ths. Right? But really, all they're asking about here is equivalent, not equivalent. Since the numerators are not equal, these fractions are not equivalent. Okay, let's take a look at number 4. They're asking me now to work back and forth with improper fractions and mixed numbers. All right, so let's make sure we talk about technique before we start solving here. When you have an improper fraction, remember what's an improper fraction? That's when the top number is bigger than the bottom number, when the numerator is bigger than the denominator, like in A here. When you have that, you're going to divide, and you're going to do basic elementary school, 2nd, 3rd grade type division, where you get to find a remainder. You don't have to worry about keeping on dividing until you finish out the decimal. The pain in the butt way, you don't have to do. You get to do the remainder thing. All right, so you're going to divide. Top number divided by the bottom number. All right, you're going to get a whole number value, then you're going to get a remainder. All right, you're going to write out that mixed number. All right, the number in front of the fraction, that's what you get when you divide. The number in the numerator is the remainder. the denominator is exactly what you had as the original denominator. All right, that's the technique there, and we'll use that in just a second here with 13/5. I'm just pointing at these parts here so you see which parts I'm actually talking about if you're not following my words necessarily. In B, they're going to have us go the other way. They're going to have us take that mixed number and change it into an improper fraction. What you're going to do there is multiply the denominator by the whole number part, and then add the numerator, and that's going to become the numerator of my improper fraction. The denominator stays the same. So either technique, the denominator stays the same. The denominator doesn't ever get changed. All right, the part that we have to work with, depending on what we're talking about, is the numerator and that whole number part, depending on, again, which route we're going. So 13/5 as a mixed number in 4a here. So I'm going to take 13 and divide it by 5. And again, all I'm doing here is second, third grade type division, not worrying about what's after the decimal and keep dividing until I use everything up. Don't have to worry about it. How many times does 5 go into 13? 5 goes into 13 twice. 2 times 5 is 10, and when I subtract, I get 3. That's my remainder, 2r3. Should look familiar to you. All right, that's all I need to write my answer here. Okay. The quotient, all right, the 2r3 here, the 2 is the whole number part of my answer in my mixed number. The 3 becomes the numerator in my mixed number, the remainder, and the denominator stays the same. Since the denominator was 5, the denominator stays 5. And that's how 13/5 becomes equivalent to 2 3/5. Now we'll check it in a minute as soon as we do part B, which is having me change 7 2/3 into an improper fraction. Directions here say to multiply the denominator and the whole number, 7 times 3, which is of course 21, and then I'm going to add the numerator, which is 2, which is 23, and it stays the denominator 3. So we end up with 23/3. All right, so now that we see that, which that's something that I think most of you are probably really good at and have done over and over and over again, and you could probably do it in your sleep. Let's go back and check this, because now I can do this, all right, the same way we did here, and that should come back to 13/5. 5 times 2 is 10. 10 plus 3 is 13. There you go. Denominator stays 5, 13/5. So not only did we come up with the answer, but we checked our work by reversing it based on what we saw in B. And of course, we could reverse B. Do 3 into 23. 3 into 23 goes 7 times with a remainder of 2. 7 in the front. The remainder goes in the numerator 2. 3 stays in the denominator 7 2/3. Okay, so let's finish up this section with the check it out examples. We're supposed to find two fractions equivalent to 3/8. So again, you've got lots of options in the world here. Doubling it is probably one you're going to choose. Remember, doubling it means multiplying both the numerator and the denominator by 2. So that's going to be 6/16. They decided to triple it as well. Again, meaning to multiply both the numerator and denominator by 3. 3 times 3 is 9. 8 times 3 is 24. 9 24ths. Again, remember the easy one I told you. Multiply by 10. Just adds a 0 as long as it's a properly written fraction. 30/80. Done. All right, number 2. Write the fraction 24/36 in simplest form. So again, we're employing the technique of finding the greatest common factor and chopping it out. So they decided here to list the factors of those numbers and then identify the biggest one that's on both lists. Now, earlier we saw using the factor trees. You can use whatever because the greatest common factor, no matter which route I follow, is the same. 12 is the biggest number that's on both lists. So it's the greatest common factor. So now I'm going to divide 12 out of both the numerator and the denominator. 24 divided by 12 is 2. 36 divided by 12 is 3. 2/3 is the simplest form of 24/36. Number 3, determine whether the fractions in each pair are equivalent. 3/9 and 6/18. Now, if you remember earlier when we had a similar question, we talked about how sometimes you only really have to change one to make this really easy instead of reducing both or making both bigger. If I multiply this denominator by 2, I get 18. So that's all I'm going to do here. I'm not even going to touch this fraction on the right. Right? I'm just going to multiply this guy by 2. Remember, whatever I have to do to the bottom, I then do to the top. So I'm going to multiply both of those by 2, the numerator and denominator. When I do that, I get 6/18. They both say 6/18. Because they both say 6/18, they are equivalent fractions. All right, let's look at number 4 here. We're writing 15/6 as a mixed number. All right, so a little bit of division would be in order here. Remember, you're going to divide numerator divided by denominator. Old school, 2nd grade, 3rd grade division. 15 divided by 6. Well, the most number of times I can feed 6 into 15 is 2. 2 times 6 is 12. 15 minus 12 is 3, which means I have a remainder of 3. That's the information I need to write my mixed number. Okay, so 2, being the quotient before the remainder, is the number that's in front of that fractional answer. Then I have the fraction bar, and then I have a number that goes above the fraction bar, the remainder 3, and then I have a denominator. The denominator is the same as it was over here, 6. Now, the catch, and I think you all see this probably already, is that's not fully simplified. The 3/6 part can actually be reduced, which is what they want us to practice here. I can take 3 out of both 3 and 6. So that's what they're going to have us do here. Chop out 3 now. When we do that, we see this reduces down to 2 and 1